Lesson 4.5, Isosceles and Equilateral Triangles. Isosceles triangles. Some things we know about isosceles triangles is that they have two congruent sides. So the angles and sides of an isosceles triangle and equilateral triangles have special relationships. So we already know that isosceles triangles have two congruent sides and the equilateral triangles have three congruent sides. So let's look at the different parts of an isosceles triangle. Well, so the angle that is at the in-between, that is the included angle between the two congruent sides, is called the vertex angle. The two sides that are congruent are called legs. And the bottom here, which is across from the vertex angle, is called the base. Now, these two angles at the bottom that are across from the sides that are congruent are called base angles. So the most important part about working with isosceles triangles is determining, when you're looking for angle measures, that is determining whether, in identifying the vertex angle and the base angles. There are two base angles and there's one vertex angle. So we'll get to more of that in a second. So let's take a look at our two theorems. Theorem 4.3 is the isosceles triangle theorem. So if I give you a diagram and you know that two sides are congruent, therefore it forms an isosceles triangle, then the angles opposite those sides are going to be congruent. So we have side AC and with side BC that are congruent, so therefore the angles A and B are going to be congruent as well. These are your base angles. Your base angles are the ones that are across from the side that's congruent. The vertex angle is the one that's in between the two congruent sides, which means that this vertex angle is the included angle. So now the converse of the isosceles triangle theorem is if you have a triangle that's got two congruent angles, then you've got the sides across from those angles are also congruent, which gives us the isosceles triangle. Now, let's take a look at this. In example 1, part A, is AB congruent to CB? So is AB congruent to CB? As we look at our figure, we have to check out to see what we know. Well, I've got two congruent angles, and I don't know anything about the side AB and BC, nothing's marked on there, but because I have two congruent angles, that is enough to determine that these sides are going to also be congruent. So is AB congruent to CB? The answer is yes. And how do we know it? Well, this goes back to the converse of the isosceles triangle theorem. So that's what we're going to write. The converse of the isosceles triangle theorem. So, these two angles are congruent, then the sides opposite those are congruent. That's what the converse of the isosceles triangle theorem says. So now let's look, is angle A congruent to angle DEA? Now remember, angle DEA, when it's written like this, is describing this angle right here, because it's formed from starting at D, going to the vertex E, ending at A. So it's referring to this angle from here to here. So, if you look right here, you have two congruent sides, and therefore, by the isosceles triangle theorem, we can conclude that, yes, these two are congruent. So the answer, once again, is going to be yes. And our reason this time is by the isosceles triangle theorem. So we have two congruent sides. We have the angles across them are also congruent. So that means these two are congruent. That means that these two are also congruent. Now, these are also, I want you to recognize that these are corresponding angles. And when corresponding angles are congruent, they form parallel lines. So that means that DE is going to be parallel to BC. So let's take a look at this. I want you to, in example 2, I want you to try part A. Okay? Take what you know about isosceles triangles and the converse to help find the measure of x. So pause your video now and come back when you're done. All right, so based on what we were given here, we have two congruent angles, base angles, which means the sides across from those are congruent. So that means we're going to take each of our expressions and set them equal to each other. Solve for x, and we get x equals 4. All right, so let's look at the next one. In the diagram, triangle PLN is congruent to triangle LNS. What is the measure of angle S in the figure below? So these two triangles are congruent. We have two isosceles triangles. So I want you to figure out how to find the value of angle S. So pause the video, come back and check your answer when you're done. All right, so what we have is two congruent triangles, so therefore our vertex angles for both should be the same. So this angle is between our two sides that are congruent, so therefore this is our vertex angle. These are our base angles, which means that these two should be the same. Now because we have congruent triangles, then these should also be the same. And so 50, and this is 50. Your vertex angles are both 50, which means your base angles, the way we'll find that is we'll take 180 degrees because there's 180 in a triangle. We'll subtract out our vertex angle, and then we have to share that between our two base angles. We have to split it evenly, so we're going to divide it by 2. So 180 minus 50 is 130, divided by 2 is 65. So each one of our base angles in this problem will be 65. Now just because these segments, these line segments here are all congruent, does not mean that every time you have congruent line segments that you'll have all congruent angles. The reason why these are congruent is because it tells us our triangles are congruent. Okay, we'll come back and practice a few more of these in just a little bit. If a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. So if I have a figure where I have an isosceles triangle and I have a line that is bisecting my vertex angle, we notice it's bisected because of these two congruent marks, then not only does it bisect it, but it bisects, this becomes a perpendicular bisector of the opposite side. So CD is going to cut AB in half, and it's going to do it at a right angle. All right, so let's find the value of x in this problem. We're given an isosceles triangle who it appears to have its vertex angle bisected. So 54 is the measure of angle A. So that means it's this angle here. So let's look to see what we know. If this angle, vertex angle, has been bisected, then this is the perpendicular bisector, which means this is a right angle. And it also means that AD is congruent to CD. AC was cut in half by this perpendicular bisector. So if this is a right angle, we know that this is also 54 degrees. And since these are congruent, this can be called x as well. So you can look at x in this side, or you can put it over here and find the value of x. So if this is a right angle, then we have two ways to solve it. We can take 180 minus the 90 plus 54. And this is going to equal x. So 90 and 54 is 144 minus 180. That's going to give us that x is equal to 36. Now a quick way to do this was recognize if this is a right angle right here, then these two angles have to also equal 90 because 90 is half of a 180. It's half of the measures of the triangle, so these two should also equal 90. So you could take x is equal to 90 minus 54, and that would give you that x is equal to 36. Much quicker, simpler way to do it, but you can also work it out by doing it, adding these two angles up and subtract from 180. So what would happen if we change this now to 27 degrees? Well, it doesn't do a whole lot. It changes our values that we get in here, but it doesn't change how we work it. It's still a right angle here because it's been bisected. So we would take the 27 and we would subtract it from 90. And x is equal to 63. So you could either add these two up, 27 and 90, subtract from 180, or just do 90 minus 27 and get 63. All right, now a corollary. A corollary is a theorem that can be proved easily using another theorem. So we're going to prove these two theorems about equilateral triangles based upon the theorems we use to prove isosceles triangles. So if a triangle is equilateral, then the triangle is equiangular. So earlier we said if in an isosceles triangle we had two congruent sides, that the angles across from those sides would be congruent. So if all three sides are congruent, then all three angles must be congruent, which means that they're all going to be the same measure. And the corollary to theorem 4.4 is the corollary to the converse of the isosceles triangle theorem. So if a triangle is equiangular, so if we know all the sides are the same, all the angles are the same, then we know that all the sides are the same. And the measures of each angle in an equilateral triangle are going to be 60 degrees. Because 180 divided by 3 is 60. So each angle would be 60 degrees all the way around. All right, so let's take a look at a few practice problems. So we're going to work a few together, and then you're going to work the rest on your own. All right, so the first one here. The first thing you want to do is identify your vertex and base angles. So these are my two congruent sides, which means that these have to be my congruent base angles. So this means that 40 is my vertex angle. So in order to find these, I have to first take 180 minus the vertex angle and divide it by 2. So that becomes 140 divided by 2, which is going to give us 70 degrees. So 70 is the measure of each of these two angles. So let's look at angle 2 now. Angle 2, in problem number 2, they give us a base angle. We're looking for the vertex angle, and they give us a base angle. We can determine that because these are our two congruent sides. This is the angle that's in between them, so that has to be the vertex. Therefore, these have to be the congruent base angles. So if they're congruent, that means that they're both equal to 75 degrees. And so to find the value of x, we're just going to go opposite of that. We're just going to take, instead of doing 180 minus 40 divided by 2, or our number divided by 2, now we're going to do 180 minus 2 times our number. So 2 times 75, if we add these up or multiply it by 2, you get 150. And now we do 180 minus 150 and get 30 degrees. So it all depends on what they've given you. This one right here is 75 and 75. These are our base angles, looking for the vertex. This one was given the vertex, looking for our base angles. So if you're looking for your base angles, you have to subtract your vertex angle from 180 and divide it by 2. And if you're looking for your vertex angle, you've got to double your base angle and subtract it from 180. All right, I want you guys to work numbers 3 and 4. So pause the video and come back and check your answer when you're done. All right, so I've got your answer for number 3 is 80, and the answer for number 4 is 122. But let's show you how this works. So these are my base angles. First thing you have to identify is, do I have a vertex or do I have the base? And these are the base because these are the two congruent sides, which means that these are the angles across from those. So that means this has to be 65 as well. So we're going to start out by taking this and subtracting 180 minus 2 times 65. Well, 2 times 65 is 130. Subtract from 180, and that gives us 50. So 50 is our vertex angle. Now, from here, we have to recognize these are vertical angles. So this is 50 degrees here. Because these are my two sides of this isosceles triangle, then these two have to be my base angles, which means they have to be the same. So this has to be 50 as well. So to find x, we're going to take 180 minus 2 times 50, kind of like we did before. And you get 180 minus 100, which gives us 80 degrees. So x is equal to 80 degrees. So let's look at this one over here. 148 is the exterior angle from here to here. Now it forms a linear pair with this line. So this angle right here and 148 should add up to equal 180. So we'll start off by taking 148 and subtracting it from 180. That's going to give us 32 degrees. So that means that this angle right here is 32 degrees. Now we don't have to find the base angles of this because we're going to try and find this angle here. So I have enough information at this point to get to this point, to get to this side over here. So this is an isosceles triangle over here. These are my base angles right here and here. So these two angles right here are congruent. Now this angle right here is a right angle. So 32 plus what will give me 90? So we're going to come over here and do 90 minus 32. And that's going to become 58. So that means this angle is 58. So because it's a base angle with this angle, that is also 58. And then x is the exterior angle that goes from here to here. So therefore, these two form a linear pair. So to get our final answer, we'll take 180 minus 58, and that gives us 122. So 122 is our final answer. So this angle right here is 122 degrees. All right, let's go to the next two, 5 and 6. So I want you to pause the video now, work these two out, and come back and check your answer when you're done. All right, so in number 5, you're going to get x equals 60, and number 12, you're going to get x is equal to 12. So let's see how we did that. They give us 120. This is an exterior angle, which means it's going to be a linear pair with its adjacent interior angle. So that means 180 minus 120 is going to give us 60 degrees. So, once again, that we have to recognize what type of angle we have. So this is a vertex angle. So we're now going to take, and we're going to do 180 minus the 2 times 60. And that's going to give us 180 minus 120, which is going to give us 60. So that these both are now 60. Through vertical angles, so we know these are congruent, these are congruent. Vertical angle tells us these are congruent. And since these are two my congruent sides, then these are both base angles. And then because it's vertical angles again, you can find this vertex angle. So our vertical angle here. So this is 60, that means this is 60. This has got to be 60 over here, and opposite of this is 60. So now let's look at this. We have where the vertex angle of our isosceles triangle has been bisected, because these two are congruent, which means that this has got to be a right angle, and these two have been cut in half. This line has been cut in half, so these are equal. So that means 12 is equal to 2x minus 12. Solving for x, we're going to add 12. 24 is equal to 2x, and divide by 2, and that gives us that x is equal to 12. All right, let's go to the next two. Work out number 7 and 8. Now this one here, once you find the measure of angle 2, you're going to plug it back in up here, set it equal to 4x minus 2, and solve for x. All right, so once again, this is an isosceles triangle. We have two isosceles triangles here. So the base angles on these two should be the same. This is 68, this is 68. So to get this right here, we're going to add 68 together, subtract from 180, and get 44. So 44 is our vertex angle. Now, this line right here did not bisect because it's not marked that it bisects it. So all we know is that this is a right angle, so angle 2 and 44 should equal 90. So I just take 90 minus 44, that gives us 46. So that tells us the measure of angle 2. So over here I'm going to plug in 46 for angle 2. 4x minus 2. So we add 2. 48 is equal to 4x, divided by 4, and x is equal to 12. So let's look now at number 8. They give us that this 118. And so I have to recognize I have a linear pair with this exterior angle. So I'm going to subtract it from 180 and I get 62. Now this is also 62 over here because these are base angles. And then we need to find this vertex angle. So we're going to take 180 minus 2 times 62. 180 minus 124. And subtract that, and that's going to give us 56. So 56 is this angle measure here. Now, 2 and 56 form a linear pair. So if I do 180 minus 56, that's going to give me 124. So this is equal to 124. So to find the value of x, I'm going to take my 124, substitute it in for the measure of angle 2, and it's equal to 12x plus 4. Subtract 4. 120 equals 12x, divide by 12, and x is equal to 10. All right, so that's the answer for problems number 7 and 8. So we got x is 12 and x is 10. So we got one more problem to do. So tip number 9, pause the video, come back and check your answer when you're done. All right, so as we look here, we have an exterior angle. We have an isosceles triangle here, an isosceles triangle over here, which means these two base angles are going to be the same. Now, because of vertical angles, that means that these two should be the same. And since these are also base angles, then this is going to be the same. So some of you may be able to look at this and say, okay, that means that this has got to be 146. And it is. Because if we subtract from 180, 180 minus 146, because it's a linear pair, that's going to give us 34, which means this is 34 degrees. Doesn't really matter what our vertex angle is because we're just going right over here. So this is 34, the other base angle. Vertical angles tell us that this is 34, which means this is 34. And then linear pair again gives us 146. So now we're going to take 146 and we're going to set it equal to 13x plus 3. Subtract 3. 143 is equal to 13x. Divide by 13. And x is equal to 11. All right, so this concludes our lesson 4.5. If there's any part you didn't catch, go back, rewind it, and watch what you did.